Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 7, Lesson 7 on factoring trinomials. Now remember, factoring is all about breaking an algebraic expression up into an equivalent product, right? Into an equivalent multiplication problem, if you will, right? Trinomials are three-term polynomials. So the thrust of what we're going to be doing today is breaking a trinomial into a product of two binomials. So let's start to begin to understand what that even means. Now, as recall, right, recall that factoring is simply the process of rewriting an algebraic expression as an equivalent product. Some trinomials, some, not all, polynomials with three terms can be written as the product of two binomials. Now again, I want to be very clear on this. There are some numbers like 17, which are prime numbers. They really can't be broken up into a product other than 1 times 17. And the same is true with trinomials. Some trinomials, they cannot be factored. They can't be broken up as a product, but some of them can. Now before we do that, what we want to do is review how to multiply two binomials together. Now I know you thought this was all over, right? A few lessons ago we reviewed 4 different ways to multiply two binomials together, but that's where we have to begin. So let's take a look at exercise 1. Find the product of each of the following pairs of binomials. Express your answers as trinomials in standard form. Use any appropriate method. Okay. Fantastic. So what I'd like you to do is pause the video now and find each one of these products. You can use the standard multiplication algorithm, you can use an area model, you can use the FOIL method, you can use double distribution. Your call. I don't care. I will say, if you want to know, that I'm going to do each one of them using the FOIL method. All right, so if you want to do it the way I am, that's where I'm going to go with, but it really doesn't matter. So pause the video now and find each of these products in standard form. All right, so as I mentioned, I'm going to use the FOIL method, first, outer, inner, last. Okay, we're going to go with FOIL. All right, so x plus 8, x plus 3. X times x is x squared. X times 3 is 3x. 8 times x is 8x. And 8 times 3 is 24. Right, combine those middle two terms, x squared plus 11x plus 24. All right, simple enough, right? Again, keep in mind, right, the first two terms, their product gives you this, the last two gives you this, and it's then the O and the I in FOIL, right, the 3x and the 8x that combine to give you 11x. Let's quickly do letter B and letter C, right? So x times x is x squared, x times negative 2 is negative 2x, 10 times x is 10x, and 10 times negative 2 is negative 20, and that's going to be x squared plus 8x minus 20. All right, finally, x minus 4 times x minus 6, x times x is x squared, x times negative 6 is negative 6x, negative 4 times x is negative 4x, and negative 4 times negative 6 is positive 24. Very important. X squared minus 10x plus 24. Now again, before we move on, I really want to emphasize something about multiplying two binomials together, right? When I look at the final answer, x squared plus 11x plus 24, that x squared comes from only one thing. The x times the x. And that plus 24 comes from one thing, the plus 8 times the plus 3. The 11x, the thing in the middle, that's what comes from the O and the I combining with each other. And that's true in each case, right? If we just concentrated on x times x, x squared, and 10 times negative 2, negative 20, right? And x times x, x squared, and negative 4 times negative 6, positive 24, right? Those things all kind of like make sense. It's the O and the I that kind of interact with each other to combine to give us this middle term. Now, the whole point of factoring will be to go backwards, to start with something that looks like this, and rewrite it to make it look like this. Anyway, let's kind of get into that. So, trinomial factoring, the big picture. When we factor a trinomial, we are trying to find the two binomials whose product will result in the trinomial. Okay, so whenever we're trying to factor a trinomial, okay, like x squared plus 8x plus 12, we want to find the two binomials that when we multiply them together give us this. So let's take a look at exercise number 2. Consider the trinomial x squared plus 8x plus 12. One of the expressions below is the correct factorization. I'm going to underline that word really quick. The correct factorization of this trinomial. Which one is it? Justify by finding each product in standard form. Okay, great. Now, each one of these is sort of reasonable to think that it could be the correct factorization of this. Factorization just means like the end result of factoring. That's it. Factorization is the end result of factoring, okay? Now, which one is correct, you can determine by literally multiplying each one of them out. So pause the video now, multiply each pair of these binomials out, and circle which one of the original ones was the correct factorization of x squared plus 8x plus 12. Pause the video now. All right, well, let's do it. In the first one, right, if I do FOIL again, x times x is x squared plus 3x plus 4x plus 12, x squared plus 7x plus 12. All right, pause for a minute. Well, is that the same as this? No, right? Because this one is x squared plus 8x plus 12. This is x squared plus 7x plus 12. So that is not the correct factorization of that. Let's try x plus 2 times x plus 6. Well, again, if I FOIL, I get x squared, all right, plus 6x plus 2x plus 12. That's x squared plus 8x plus 12. We step back, we look, is this the same as this? And the answer is yes. So in other words, this is the correct factorization. I'm going to do the last one in just a moment, all right? But this one is correct, right? And again, that's all I'm looking to do. I'm just trying to figure out if I'm given a trinomial, what two binomials, when I multiply together, would give me that trinomial. All right? It's the same thing we're always trying to do with factoring. In this final one, though, we get x times x, which is x squared, x times 12, which is 12x, 1 times x, which is x, and 1 times 12, which is 12. So I'd get x squared plus 13x plus 12. And again, not correct because it's not the same thing, right? When I multiplied these two out, I didn't get this. You know, this is no different than if I said factor the number 30, right? You know, if you then wrote down 15 times 4, well, that wouldn't be the correct factorization of 30 because 15 times 4 isn't 30. It's that easy. But if I said factor 30 and you said, oh, 3 times 10, I would say, bingo, beautiful. That is the correct factorization of 30 because 3 times 10 is 30, right? That is all we're getting at here. We need to try to find the binomial pair that when you multiply them together gives you the original trinomial. All right, so how do we do that? Well, we are going to concentrate in this lesson and generally in this course with what are considered easy trinomials. And those are specifically trinomials with a leading coefficient equal to 1. What do I mean by that? That means it will always be x squared. It won't be 2x squared or 5x squared or 3x squared. It'll be x squared. So here's a trinomial with a leading coefficient of 1. Here's one with a leading coefficient of 1. Here's one with a leading coefficient of 1. So it's trinomials like this that we're going to concentrate on. And in fact, trinomials with leading coefficients equal to 1 are very common, especially in Algebra 1. We want to develop a pattern that will help us factor these types of trinomials, okay? So let's take a look, before we do factoring, let's take a look at a general pattern in exercise number 3. Consider the general product x plus a times x plus b, where a and b are positive or negative integers. Write this product in standard trinomial form. Oh my. Okay, well, let's do this together. I want to talk about this. All right, let's put down x plus a times x plus b, and again, I'm going to do foiling, but you could do whatever you want. X times x is x squared, right? A times x is a times x, and b times x is b times x, and then a times b is just, well, a times b. All right. Now, this is not a trinomial, right? Because it's got 1, 2, 3, 4 terms. 4 terms. But I can make it into a trinomial by writing it like this. Now it's a trinomial. 1, 2, 3 terms. Now, what does this pattern really tell us? It tells us that whenever we multiply something that looks like ax plus a times x plus b, that the coefficient that's multiplying the x to the first term is simply the sum of these two numbers, a plus b, all right? And of course, one of them could be negative, both of them could be negative. And then the constant that's added on is their product. Let's see if you understand that in letter B. Letter B. If the trinomial x squared plus 7x plus 10 was written in the form x plus a times x plus b, then fill in the following about a and b. Well, what would a plus b be equal to? What is a times b? Well, if we compare this to this, then what we know is that this will be a plus b, and this will be a times b. So in fact, you always get something that looks like this. Right? If a and b are the two numbers, inside of the parentheses, then when we multiply them out, we always get x squared plus the sum of those two numbers times x plus the product of those two numbers. Now, how in the world does this help us? Well, let's see how we can use that pattern to factor. All right, so the binomial product pattern. The product x plus a times x plus b results in the trinomial x squared plus a plus b times x plus a times b. This pattern can be used to multiply two binomials as well as to factor a trinomial. Let's see how we can use it to factor a trinomial. Exercise number 4. Use the pattern you just learned to factor each of the following trinomials into the product of two binomials. All right, so my first one is x squared plus 11x plus 24. And I like to think about this as kind of almost like a little game, right? I'm looking for two numbers, right? I'm trying to fill in this kind of pattern, right? And what I know right now is that the two numbers add to be 11, and the two numbers have a product of 24. So I want to think and figure out what two numbers have a sum to 11 and have a product of 24. Now, I don't like to think about the sum first. I like to think about the product first, and primarily that's because there's a lot of numbers that sum to be 11. 10 plus 1, 9 plus 2, 8 plus 3, 7 plus 4, right? A lot of numbers have a sum to 11. There's less numbers, though, that have a product of 24, right? So if you think about it, right, two numbers that have a product of 24 would be like 2 times 12, right, 3 times 8, 4 times 6, well, and even 1 times 24, right? So all of these numbers, 2, 12, 3, 8, 4, 6, and 1, 24, they all have a product of 24. But which one amongst these pairs has a sum of 11? Well, that's 3 and 8. And so what that tells me is that this trinomial factors into x plus 3 times x plus 8, right? X plus 3 times x plus 8. And again, if you multiplied them all back out using FOIL or double distribution or area or whatever, you would get x squared plus 11x plus 24. Think about it. X times x is x squared. 3 times 8 is 24. and then we'd have a 3x and an 8x when we did our FOILing. Those would add up to be an 11x, so that must be correct. All right, let's do another one together. In letter B, right here, we see that the sum must be 12 and the product must be 20. So you want to play this game, right? What two numbers have a product multiply to be 20, but have a sum of 12? And again, a lot of students will say, well, 20 is 2 times 10, or 4 times 5, or 1 times 20, right? So then this would sum to be 12, this would sum to be 9, this would sum to be 21. That's the first one, right? It's 2 times 10. So this thing must factor as x plus 2 times x plus 10. It's as easy as that, all right? Now again, this little pattern only works if the leading coefficient on x is equal to 1. If that's a 2x squared, a 3x squared, a 4x squared, then this becomes a much more challenging process, okay? And we'll look at that a little bit towards the end of this unit. But for now, we're only going to worry about this. What I'd like you to do is pause the video now and see if you can factor x squared plus 17x plus 30. All right, well, we know whatever those two numbers are, they must have a sum of 17 and a product of 30. 30 is kind of nice. It's 2 times 15, or 3 times 10, or 5 times 6. The one that has a sum of 17 is 2 and 15. So this must factor as x plus 2 times x plus 15. And that's it, right? Now, we're going to look at some more challenging situations in just a moment. But at the end of the day, this is basically it. If you can play this game and figure out the two typically whole numbers that have a particular sum and a particular product, then factoring these types of trinomials is going to be quite simple. Let's take a look at some twists on this, though. Some things that make it a little more challenging. Now, factoring using sums and products is harder when there are negatives or subtraction become involved. Let's take a look at exercise number 5. Consider the trinomial x squared plus 4x minus 12. What two integers have a sum of 4 and a product of negative 12? So again, it's still that sum and product, right? The sum is still positive 4 and the product is negative 12. Now, keep in mind, if two numbers have a product that is negative, one of them and only one of them must be negative. One of them and only one of them must be negative. So I'd like you to pause the video now and see if you can think of two numbers that have a product of negative 12, but when you add them together, right, and one's got to be positive and one's got to be negative, stuff cancels out to have a sum of just 4. Pause the video now and see if you can figure it out. All right, well, again, if I think just about my negative 12, right, that could be negative 3 times 4, or 3 times negative 4, or it could be 2 times negative 6, or it could be negative 2 times 6, or it could be 1 times negative 12, or it could be negative 1 times 12. Right, those are all kind of our possibilities. That's all we got. Now, if you think about it, if you have a negative and a positive and they add together to be a sum of positive 4, the larger one has to be the positive one, right? And they have to differ by 4. So here they are, right? It's going to be negative 2 and 6, right? Negative 2 plus 6 is 4, and negative 2 times 6 is negative 12. Right, those are my two numbers, negative 2 and 6. Letter B, use your answer to A to help factor the original trinomial. Piece of cake now, right? Because now it's just going to be x minus 2 times x plus 6. Again, I want to emphasize, if you wrote down x plus 6 times x minus 2, awesome. Nothing wrong with that. Multiplication is commutative. Doesn't matter whether I have x plus 6 times x minus 2 or x minus 2 times x plus 6. Now, be very clear though. What would definitely be wrong is if I had x plus 2 times x minus 6. That would leave me with a negative 4x here, right? So be careful. That's not what I'm saying. All right, let's take a look at exercise number 6. Consider the trinomial x squared minus 11x plus 18. What two integers have a sum of negative 11 and a product of positive 18? Now again, I want you to think about this for a second. Two numbers can have a positive product, right? A positive product of 18 if both numbers are positive or both numbers are negative. Now, the only way we can sum the two numbers and have a negative sum is if they're both negative. So whatever my two numbers here are, they both have to be negative. So pause the video now and think about this a little bit. All right, remember, they've got to both be negative. All right, if one of them's negative and one of them's positive, they aren't going to have a product that's positive. And if they're both positive, they're not going to have a sum that's negative. That's not going to happen. So if I think about 18, right, it could be, negative 3 times negative 6, or it could be negative 2 times negative 9, or I suppose it could be negative 1 times negative 18, right? It could be one of those three pairs, right? If I added negative 3 and negative 6, I'd have negative 9. If I added negative 2 and negative 9, I'd have negative 11. And if I added negative 1 and negative 18, I'd have negative 19. So this is my winner. X, right, negative 2 and negative 9. Right, negative 2 plus negative 9 is negative 11. And negative 2 times negative 9 is positive 18. All right, so those are my two numbers, negative 2 and negative 9. Letter B, use your answer to A to help factor the original trinomial. It's now simple. X minus 2 times x minus 9. Simple as that. That is it. Every factoring problem can be basically boiled down into every factoring of a trinomial problem with a leading coefficient of 1, all those kind of little caveats, can be broken down into one of the previous three examples that we saw. Of course, the key is you gotta be able to put them together when you need to. It's critical to become fluent with this type of factoring, as it will come up in a lot of additional problems in this course. Now again, it all boils down in every one of these cases, right, to trying to find two numbers who have this product and this sum. So a product of 40, a sum of negative 13. A product of 21, a sum of negative 10. A product of negative 16, a sum of negative 6. All right? And it's really critical that you're comfortable with the idea that a negative times a negative is a positive, that a negative plus a negative is a negative, that a negative plus a positive could go either way depending on which of the numbers has a larger absolute value. All right? So let's do the first row together. Then we'll have you do the second row on your own. So exercise number 7. Factor each of the following trinomials by writing it as the product of two binomials. Letter A, x squared plus 13x plus 40. All right, so this is the best case scenario. Everything is positive. So I'm looking at 40, I'm thinking what two numbers give me a product of positive 40, right? They've both got to be positive because their sum is positive. Right? So I think about that, right? What two numbers have a product of 40 and a sum of 13? And that's going to be 8 and 5, right? 8 times 5 is 40, 8 plus 5 is 13. So this factors as x plus 5 times x plus 8. All right. Now letter B, I'm looking for two numbers that have a product of positive 21 but a sum of negative 10. Now, as soon as they have a positive product and a negative sum, it tells me both numbers must be negative, right? And what two numbers are those? Well, those are negative 3 and negative 7, right? When I multiply negative 3 times negative 7, I get positive 21. And when I do negative 3 plus negative 7, I get negative 10x, or negative 10. So I get x minus 3 times x minus 7. All right. Probably the hardest one of all for students is the situation that you find in C, where you have a negative product, and as soon as you have a negative product, one number is negative and one number is positive, and then you have some other sum. In this case, the sum's negative. Now, whenever the sum's negative, that means that the larger number, absolute value-wise, must be negative. So what two numbers, right, have a product of negative 16 and a sum of negative 6? Well, those two numbers would be 2, positive 2, and negative 8, right? 2 plus negative 8 is negative 6, and 2 times negative 8 is negative 16. And at the end of the day, that means x plus 2 times x minus 8. All right, that's it. So what I'd like you to do now is pause the video and see if you can factor the remaining 3. Take a few minutes to do that. All right, so letter D. I've got a product of negative 44 and a sum of positive 7. One's got to be positive, one's got to be negative, and the larger number absolute value-wise has to be positive for their sum to be positive. Well, 44 is kind of nice, because when you look at it right, instantly you're probably thinking 4 times 11, maybe 2 times 22, right? But 4 times 11 I like, because 4 and 11 can combine to be 7 through subtraction, right? So I'm thinking negative 4, positive 11, right? Which will give me x minus 4 and x plus 11. Again, if you wrote down x plus 11 times x minus 4, you're golden. Just make sure you don't have x plus 4 and x minus 11. That would be wrong. Letter E, best case scenario, everything's positive. I'm looking for two numbers whose sum is 20. Whose product is 20. I really apologize for that. Whose product is 20 and whose sum is 12. Now again, 20 is kind of cool because you got 2 times 10, 4 times 5, 1 times 20. But the two numbers with a product of 20 and a sum of positive 12 are 2 and 10, right? 2 times 10 is 20. 2 plus 10 is 12. So we get x plus 2 times x plus 10. All right. And finally, I think one of the trickiest ones here, letter F, I'm looking for two numbers whose product is positive 8 and whose sum is negative 9, right? Now, again, if I've got a positive product and a negative sum, the two numbers must be negative. They must be. So what gives me a product of 8? Well, 2 and 4 and 1 and 8. That's it, right? Now, 2 and 4, 2 plus 4 is 6, 1 plus 8 is 9. Looks like it's negative 1 and negative 8, right? X minus 1 times x minus 8. Again, I want you to always keep in mind, there is no reason you should ever miss a single one of these. Not because you know a lot about signed numbers and things like that, but because you should now be able to multiply each one of these things out to see if it's equivalent to what you started with. And if it's not, then you factored it in correctly. It's that simple. All right, let's wrap this up. So, factoring trinomials comes up a lot in Algebra 1. A lot. Okay, we're going to see it tons in the next unit. Okay, and the most common factoring of trinomials occurs in trinomials where the leading coefficient is equal to 1. So these are trinomials that look like x squared plus something plus something. You know what I mean? So there's always just 1x squared or m squared or t squared or whatever it is. All right. When you factor ones like that, if they can be factored at all, right, it's all about looking for two numbers that have a sum equal to whatever the coefficient is on the x to the first term, and who have a product of the constant of the trinomial. Once you have that, it's very easy then to factor the trinomials. We're going to get a lot of practice on this in the next lesson and on lessons going forward. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.